Hey guys, I have your notes pulled up for section 2.5 day 1. But before I actually show you and get to those notes, I've given you 4 scenarios on like possible solutions to a quadratic equation. And I've drawn a picture for you as well. So I chose a quadratic because I think you're pretty familiar with quadratics. You know how to solve them. Most of you try to factor them first, and you know if they're not factorable, you've always got your quadratic formula. So I've got, I think, like one of 4 things is going to happen when you're solving a quadratic. So the most common situation is when you're solving a quadratic, it is able to factor. So I've highlighted my 2 factors, and I get 2 solutions, right? So I can say that this quadratic has 2 zeros. Here's what it looks like on a graph. Opens up. Here's where it crosses the x-axis. Keep in mind, these zeros are real, not imaginary, and they are rational. Here's something else that might happen when you're solving a quadratic. It's able to be factored, but yet you get the same factor occurring twice. And therefore, it looks like you only have 1 solution or 1 zero. And that's true. Just happens that that 1 zero occurs twice. What does that matter? That means that your graph only touches at that 0 or at that x-intercept. Okay, so it occurs twice. Keep in mind, this solution is real, not imaginary, and it's rational. Here's something else that can happen when you're solving a quadratic. If it's not factorable, then you can use the quadratic formula. Did that, did that, did that. I got, underneath my radical, when I did b squared minus 4 times a times c, I got positive 12. Okay, so I got a positive number under my radical. That's not a perfect square, so I had to simplify it. Turns out my 2 solutions are negative 1 plus radical 3, negative 1 minus radical 3. And because I'm not square rooting a negative, I can say that my solutions are real. They're real. But because they have a radical, they are irrational. They're real, so there's no imaginary yet, but they're irrational. And if you tried to do this on your calculator, you would get a yucky decimal. The decimals are approximately, I think it was like 0.7 and negative 2.7. So I graphed them as, I just kind of estimated through the graph. It has 2 zeros. They're real. They're not imaginary. And they're irrational because they have a radical in them. All right, and then I know you know a parabola doesn't have to cross the x-axis. Still has 2 zeros though. You just can't see them. They're imaginary. So I try to factor, it won't factor. I'm going through my quadratic formula, only this time when I'm doing my quadratic formula, I get a negative number under my radical. So when I simplify the square root of negative 64, this time I get an imaginary number. So I simplify it. Here are my 2 solutions, negative 3 plus 4i, negative 3 minus 4i. I get 2 zeros. They're not real. They're imaginary. So I hope that makes sense to you because you've encountered all these situations at different times, in different sections, in different years of school at FC. This is like putting it all together. We got all the vocab here. We've got all the possible solutions. We got imaginary, real, rational, all that stuff. Hopefully that makes sense. Also, notice that up here I highlighted our factors in pink. That's what I've been using for factors. And down here, there are no factors. They're not factorable, because these solutions were irrational and those solutions were imaginary. going to move on to your notes. And we are getting to the point where you're going to be given like a cubic or a quartic or a quintic or something like that. And you're not going to be good at it. You're not going to be good at solving it. You need a place to start. If I can show you how to get started or tell you, like, this is where you're going to start. If I give you a starting place or I show you how to do it on your own, that's what you need, because you're probably not going to be good at factoring higher level polynomials. So this is one. This looks awful. I know this. This is one way that back in the old days, old school, before graphing calculators, this is one way people could get started finding solutions to a polynomial. So let's say that there was this fourth degree polynomial and I want to find some zeros. Like, well, where do I start? Well, here's one way that they would have started back in the day. This was way before my time, okay? They do the rational zero test. The rational zero test only gets you possibilities for rational x-intercepts. You know what rational means, right? Those were irrational. These were rational. So like nice integers or nice ending decimals, like 1.5. It's a nice decimal. Oops. Okay, so possible rational zeros. Here's what you're going to do. We would take our polynomial and we would look at two numbers. We would look at the leading coefficient and we would think about all of its factors. So the leading coefficient of 2, the factors of 2 are 1 and 2. We would kind of write them out. And then, back up to the polynomial, we would look at the constant term, the term at the end without a variable on it. And we would look at all of its factors. Okay, think about what numbers go into 18. 18, 1, 9, 2, 6, 3. List them all. So the factors of 18 are, in order, all those. Remember, we're trying to find a place to start. Where do we even start? Don't know. Well, here are some possibilities. Ready? Possible rational zeros. Here's what you're going to do. Take every single one of your factors of your constant term. Use the positive version and the negative version, and put them all over each factor of your leading coefficient. So remember what the factors of the leading coefficient were? 1 and 2. So let's do positive this number over 1, positive this number over 2, negative this number over 1, negative this number over 2. Positive this number over 1, positive this number over 2, positive this number, okay. On and on. So the quickest way that I can write that is let's do positive negative 18 over 2, positive negative 18 over 1. Now the 9. Positive negative 9 over 2, positive negative 9 over 1. See what I'm doing? I'm taking each of these numbers, positive and negative versions, and putting them over each factors of my leading coefficient. I did the 6's over 2 over 1. I did the 3's over 2 over 1. I did the 2's over 2 over 1. And I did the 1 over 2 and over 1. Holy moly. Think about this. That's 1, 2. This is 2 numbers, so I got 24 possibilities. 24 possibilities for a maybe on a rational zero for that 4th degree polynomial. 24 possibilities. Now, I simplified each one of them. So positive negative 18 over 2. I simplified positive negative 18 over 2 to positive negative 9. Positive negative 18 over 1, simplified. Couldn't simplify that one. 9, oh, already had it. 3, 6, that one couldn't simplify. 3, already had it. 1, 2, 1/2, already had it. So since I had some duplicates in there, really, I only have 18 possibilities, not 24. So back in the day, you know what they would have done? They would have taken positive 9, sent it through with synthetic division, hoped for a remainder of 0. If that didn't work. Negative 9, send it through synthetic division, hoped for a remainder of 0. And so on and so on. Now, don't worry. We're not going to ask you to do this. We're not going to ask you to find all of the possibilities, now start trying them. There is a question, there will be a question on your test where it says, find the possibilities. There won't be this many, but this is a lot. There are a lot of possibilities here. And when we have you do them, you won't have that many possibilities. But we will ask you to do the possible rational zero test. Just list the possibilities. We're not going to make you go to all the trouble of plugging everyone in to see if they work. Just know the test. All right, moving on. Here are some ways where, again, sometimes, some of these mention graphing calculator, so that's nowadays. But intermediate value theorem, that can be done. Synthetic division, Descartes' rule of signs. This is in your textbook. If you want to look it up, you can access your textbook in MyMathLab. Upper and lower bound test. We'll talk about that tomorrow. So, tell you what, there are a lot of ways to start narrowing down your possible zeros. Most of the time, I'm going to give you a place to start like I did yesterday. Hey, I think this is a factor. Check it out, see what you can do with it. And then you did. Today we're going to start looking at your graphing calculator. Anyway, fundamental theorem of algebra. So this is your guarantee, like whatever your degree is. If you've got a cubic, you're guaranteed to have 3 zeros. They might repeat, so they might all look the same, or they might be some of them might be imaginary. If you've got a 5th degree, you're going to have 5 zeros. They may repeat, some of them may be imaginary, but you're going to have 5. Okay? Linear factors. This just means you should be able to take every single one of your zeros and turn it into a factor, right? The yellow is what I've been highlighting for our zeros. Turn that into a pink factor. You should be able to do that. And this might be something brand new to you. So if you have imaginary solutions, you won't just have one imaginary solution. It's always going to have a partner. Imaginary solutions always come in pairs. Think about this. The parabola doesn't cross the x-axis at all. There's no way to just get one imaginary solution and the other one be real. There's no way I'm going to make this cross once. It either crosses twice, 2 real, touches, 2 real, but it's the same one repeated, or it doesn't cross at all. to imaginary, okay? Imaginary solutions are always going to come in pairs. Whatever one of your imaginary solutions is, the other one is called the, you should know this, complex conjugate, right? The real part didn't change, only the sign of the imaginary part changed. So those are always your partners on dual imaginary solutions. Okay, and then a couple of quick questions here. Hey, you've got a fifth degree polynomial. How many zeros does it have? 5. Easy. Hey, you've got this polynomial. Oh my goodness, look. This is to the 4th power. X times X times X times X. Times, and then you're going to do it again and again and again. And then you're going to times again and again. What degree is that? It's a 9-degree polynomial. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a 9th degree polynomial. How many zeros is it going to have? 9. What are they? Here's one, here's one, here's one. But wait, that's only 3. Well, yeah, 3. But this one happened 4 times. -2. The multiplicity on that one is 3. And the multiplicity on 5/3 is 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. There are your 9 zeros. And if 3 minus 7i is a 0, what's its partner that's going to go with it? 3 plus 7i. It's the complex conjugate. All right. On the back, we have a cubic function. And it says to factor it completely and find all the zeros. And I gave you nowhere to start. I didn't say, hey, I think this is a factor, try this. I didn't say, hey, I think this is a 0, try this. So I didn't give you a place to start. How about factoring the way you know how to factor? Do you have a common x that you can pull out? Dang. Can you factor by grouping? No. So it's not factorable by any means that you know how to factor. I didn't give you a place to start. So when this happens, you're going to go to your graphing calculator. You're going to go to your y equals, you're going to graph it, you're going to see what the graph looks like. Here's what the graph looks like. It's a cubic. It looks to me like it crosses the x-axis 1, 2, 3 times. I think it crosses at x equals 5. I think it crosses at x equals 2. And I think it crosses it somewhere, I don't know where. Somewhere between 0 and -1, okay? We'll find that place in just a minute. So what I'm going to do is I'm going to grab one of these nice zeros. Okay? I've got 2 of them here. I've got 2 nice zeros. Grab one. Doesn't matter which one. I think I'll grab the 2. Grab the 2, send it through synthetic division. When you send 2 through a cubic with synthetic division, what are you going to get as a result? You're going to get a quadratic. So, synthetic division, 2 went through, oh, look what happened. Huh, we were right. 2's a 0. Now, take this quadratic, and now send the 5 through. So I've used both of my nice ones. I've used the 2, I've used the 5. Look what happened. Remember, this was a quadratic. So when I send 5 through a quadratic with synthetic division, what do I get? Linear. 3x plus 1. So that's my remaining factor, 3x plus 2, 3x plus 1. And the solution to that, what would make that 0? That would be negative 1/3. Okay, so here's what we've got. We knew from the very beginning, we thought this was a 0, we thought this was a 0. We sent them through, check, check, they were. And we got this one as our last one. And so I know that this is a factor. It said it right here. So I know 3x plus 1 was a factor. 3x plus 1. Okay, so this goes with this 0. Give me the factors that go with these zeros. Well, for the positive 2, the factor should be x minus 2. And for the positive 5, the factor should be x minus 5. Factors, zeros. Okay, next one, kind of similar. Here's a 4th degree polynomial. Good luck. Y'all aren't going to be good at this. You're not going to be good at factoring, solving, whatever, a 4th degree polynomial. You need a place to start. I either need to tell you, here's a factor, start here. Here's a 0, start here. Or graph it on your graphing calculator. Try to come up with 1 or 2 or 3 or 4 on your own. So when I graph this on my graphing calculator, I think I see an x-intercept of 2. But wait, it touches. It touches at 2. That means that I think this 0 occurs twice. What do we do with that? Hang on, I'll show you. So grab a 0, send it through. Grab a 0, send it through. So I've got 1, -1, -1, -1, -16, 20. Okay, 2 is a 0. So think about what we just did. We started with a 4th degree. We sent a 0 through. We now have a 3rd degree. Here's what it is. You ready? X cubed plus x squared plus x minus 14. Good luck with that. What are you going to do? I don't know. You know how to factor it? No. Have we used all of our zeros that we found? No. We used one of them. Let's use the other one in our cubic. Because what we want to do is we want to get it from a 4th degree down to something like manageable, like a quadratic. Y'all are good at quadratics. Let's do what we can to take this 4th degree to a 3rd degree. We're still not good at those. Down to a quadratic. We're good at those. So send your next 0 through. Send that one through. Your cubic. So I'm going to go 1, 1, 1, negative 14. 1, 1, 1, negative 14. This was a cubic. We sent a 0 through. I have a quadratic. Y'all are good at these. 1x squared plus 3x plus 7. Okay, keep going. Should have 4 zeros. We've discovered 2 of them. We need the last 2. Okay, so I'm going to set my quadratic equal to 0. Oh, I'm going to hope it factors. What do you think? Do y'all think it factors? Nope. Silly. If it factored, I would have more real x-intercepts. I don't have any more real x-intercepts. I have found 2 real ones. The other 2 have to be imaginary, which means we're going to have to use the quadratic formula. All right, and that's kind of lined out for you down here. We tried to factor, that's not going to work. We're going to use the quadratic formula. Here's what you get. You get 2 answers, -3 plus all that over 2, -3 minus all that over 2. Okay? These are imaginary zeros. And those are my real zeros. Okay? Big takeaway from this is you need a starting place. We'll either give you a starting place or you'll have to come up with a starting place on your graphing calculator. You want to use synthetic division over and over and over again to get your polynomial from wherever it starts, whatever degree, get it down to a quadratic that's manageable. You're good at quadratics. Get it down to a quadratic.